3.2. Rolle's theorem and mean value theorem. Two very important theorems. They're basically the same thing. It's just Rolle's is more specific. So let me actually start with mean value. If f, a function, is continuous on an interval, closed, and differentiable on the open, then there's at least one number c where the derivative equals the slope between the 2 points. If I have a point here and a point here, okay, closed interval AB, if I have 2 points, if I have a graph that goes through those 2 points that is continuous, is this orange continuous? It's continuous, and is it also differentiable? Meaning, does it have a derivative everywhere on that graph? So it's continuous everywhere on the graph between the 2 dots, and it's differentiable. If that's a situation, then there is at least one number c where the derivative equals the slope of those 2 dots. Meaning, if I found the slope of these 2 dots, it's called a secant line. Do you understand there's somewhere between those 2 dots on this orange line that has the same slope as that green line? It's right here. Now, if there was a certain graph, could there be multiple spots on the graph where it has that same slope? Yeah. Okay. Let me restate that. Mean value theorem. Mean means average. Isn't this your average slope from here to here? In that interval, isn't that your average slope, the secant? That's this. Isn't that slope? F of b minus y2 minus y1, x2 minus x1. What it's saying is, again, if from these 2 points, if your graph is continuous and differentiable, just be careful about the closed and open intervals. But if it's continuous and differentiable, you can guarantee there is at least one point. There is at least, meaning there could be more, but there is at least one point between those where it has the same slope as that secant line. That's the mean value theorem, because it's talking about mean, average slope, value theorem, and there's some other point there. And our goal will be then, what are those points? But at first it's just saying there is at least one. Rolle, a guy named Rolles, I don't know his last name, Rolle, I don't think there's a apostrophe somewhere there, one of those accent marks. It's exactly the same intro. If the function, see how this introduction is the same as this one? Except it has this extra piece. It has an extra piece where f of a equals f of b. Then there's at least one number c where the derivative equals 0. Here's what it means. If f of b equals f of a, do you understand? My 2 points are flat. Aren't my 2 outputs flat, the same height? So do you understand what's my secant line slope?
0.
So if I have a flat line, because the values are the same, so isn't my secant 0? So if I make this graph like that, is there at least one point between those 2 red dots that has a slope of 0? There's actually 2, but there's always going to be at least one. Yeah. In this situation, there are actually 2, but there are always, it will be at least one point, as long as it's continuous and differentiable, there will always be at least one point that has a slope of 0. So isn't this the exact same thing as this? But the only difference is, aren't my 2 points the same? They're level. They form a slope of 0. So their answer means they form a slope of 0. So basically, Rolles really created something very ingenious. He basically said, mean? Okay, make the 2 dots flat. Yay, I got my name on a theorem for the rest of my life. I'm dead, but anyways, so it got really popular for some dumb reason that he really hard out, that 2 points are flat, forms 0 slope. That's kind of too easy. But somehow he got his name on it, and so 2 points, get a slope of 0. Not very complicated. It's basically this with an extra step.